Okay, let's get started with part 2 of 6.3. All right, so with the proportions, the P, we also have a formula for sample size, just like we did in 6.1. It does look a little bit different than the one in 6.1. We have P hat and Q hat out front. We still have the normal Z of C, and we have the margin of error, and then we're raising that to the power of 2. Now, the one difference when we're just using the formula is that sometimes they don't give us P hat and Q hat. And so if they do not give us P hat and Q hat, we're going to go ahead and just use 50-50. So 0.5 and 0.5. All right, let's try one of these. All right, so let's take a look at what they've given us here. So you are running a political campaign and wish to estimate with 95% confidence. So we know that 95% confidence means that C, our confidence level, is 0.95. And because we're doing sample size, we're going to need Z of C. We're going to need that critical value. So if you go to your resource sheet, you'll see on the bottom, it has the critical values for 80%, 90%, 95%, and 99%, I think. And so if you look at 95%, you'll see the 1.96. So we're going to need that in a few minutes. Okay, so we want to estimate within 95% confidence the population proportion of registered voters who will vote for our candidate. Okay, your estimate must be accurate within 3%. Okay, so this accurate within 3%, that means that's our margin of error. And so that means that E is going to be 0.03. So remember, there's different wording for margin of error. Sometimes it says literally margin of error. Sometimes it says E equals. And then sometimes this, the words about accurate within are going to be there. But no matter what, that's your margin of error. So we're going to find two minimum sample sizes. The first one is if no preliminary estimate is given. In other words, they don't give us P and Q. And so if they don't give us P and Q, we're going to use 0.5 for both of those, right? The 50-50. So we're going to take our formula here for sample size. We're going to put 0.5 in for P hat, 0.5 in for Q hat. We're going to come over here and put our 1.96, that's our Z of C. And finally, we're going to put our margin of error in the bottom, 0.03. Now, don't forget to square up here. I do that sometimes and then I get a crazy answer. Now, just like in section 6.1, we are going to round up no matter what because we want to be on the safe side and make sure that we have a large enough sample size. It never hurts to have a bigger sample size. It does hurt to have a smaller. And so in this case, we have 1067.11111. As long as it's just a little bit over, we are going to jump up to the next number. So we are actually going to go to 1068 for our sample size. All right, so let's come over here and do it again. So that's the first answer. The second one literally gave me P. It said that P hat was 0.31. And so what I'm going to do is subtract that from 1 to get Q hat. That means Q hat is 0.69. Okay, remember those two together have to sum to 1. And so now I'm going to use my formula again. I have P hat of 0.31, Q hat 0.69. I have my critical value, Z of C, of 1.96. I have my margin of error on the bottom, 0.03, and then I'm going to square that. When I do that, I get 913 plus a tiny little bit. And so I am going to round that up to 914. Even though it's only a tiny decimal after, I'm still going to go up to the 914 to be on the safe side. Okay, so let's take a look at what these are going to look like inside our homework. So this one says that a study of 4,610 adults from country A. So that means that's our N. That's our sample size, 4,610. Then it says 2,585 think mainstream media is more interested in making money than telling the truth. So for us, that is our success. All right, those are so 2,585 people are deemed as a success for what we're looking for. We're looking that they think that the media is more interested in making money than telling the truth. So then we're going to come over here. We're going to put our number of successes on top, our sample size on the bottom, and then we're going to get our p hat. So p hat is 0.561. And that's going to go in the first box. Then they're going to ask us for Q hat. Well, Q hat is just 1 minus P hat because those two together need to get me to 1. And so if I subtract 1 minus 0.561, which is P hat, then I get 0.439, and that is my Q hat. And that's all that this problem wants us to do. Okay, so here's another problem that is like what we're going to see in our homework. It says in a survey of 2,311 adults, 707 say they believe in UFOs. Construct a 99% confidence interval for the population proportion of adults who believe in UFOs. All right, so they told me that we had 2,311 adults that we surveyed. That's our sample size, that's N. They said that 707 believe in UFOs. That's our X, that's our number of successes. And then finally, they asked for a 99% confidence interval. And so that would be 0.99. We don't have to find our critical value for this one because StackCrunch is going to do it for us. It's only when we're doing the sample size, the minimum sample size. Okay, so we're going to go to proportion stats, one sample with summary. We're going to put in our number of successes, that's 707, our number of observations, which is our sample size, 2,311. We're going to hit our confidence interval and put 99% in here, so 0.99. Then, as soon as you hit compute, the computer's going to do it all for you. So you've got your lower limit of 0.281, you have your upper limit of 0.331, and you're able to make a confidence interval. And so we know that we're 99% confident that the population proportion would lie somewhere between those two numbers. All right, let's try another minimum sample size. So let's see what the problem gives us. It says a researcher wishes to estimate with 90% confidence. So 90% confidence means that our confidence level is 0.90. If we go to our resource sheet, we see that that means that the critical value would be 1.645. Okay, that's on the bottom of the first page of the resource sheet for chapters 5 and 6. All right, then it says we want to estimate the population proportion of adults who think Congress is doing a good or excellent job. The researchers' estimate must be accurate within 3%. So that means that that's the margin of error. Therefore, E is going to be 0.03. We're going to change it back to a decimal. Okay, so I think we have everything we need. We've got C, we have Z of C, our critical value, we have our margin of error, and we have our formula. We have, because it's asking for minimum sample size. As soon as it asks for that, go to your resource sheet and find your formula for that. Okay, so let's fill in what we know. Notice they didn't give us P or Q, right? There was no P or Q, and therefore we're going to use the 0.5 because they didn't tell us otherwise. So P hat is 0.5, Q hat is 0.5, The critical value Z of C is 1.645. We found that from our resource sheet. And then our margin of error is 0.03, and we're going to square that. So as soon as we do that, we get 751.67. We're going to round that up. And our answer is that our sample size needs to be 752 people that we want to talk to if we want a 90% confidence and a margin error of only 3%. All right, so this is the continuation of that same problem. So we still have the same Z of C, we still have the same margin of error, but this time they tell us that a prior study found that 20% of the respondents think Congress is doing a good job. So this time we're going to use that 20% as p hat. So that's going to be 0.20. We need to find q hat. So q hat is just 1 minus p hat. So if you take 1 minus the 0.20, you get 0.80. So now we have everything we need. We're going to put p hat in here for 0.20. We're going to put q hat 0.80 here. We're going to put our Z of C in here, 1.645. And finally, we're going to put the margin of error of 3% in the bottom, square that. We get 481.07. And so we're going to round up, because even though we're just a little bit past the 481, we're going to go ahead and jump to the 482. All right, so at this point, they want to know what happens if you don't have the estimate for P versus you do have the estimate for P. So when we didn't have it, we had numbers, we needed a sample size up in the 700s. When we did have an estimate, now we're down to only needing 482. So it actually reduced the minimum sample size needed. All right, this is a tricky problem because there's a lot to do. So let's take a look at what's going on here. They tell us we want to find the level C. So that's why it's going to take us a little bit of work. So in a survey of 1,021 adults, that means my N is 1,021, 79% said being able to speak the language is at the core of national identity. So that means that my p hat is 0.79. 1 minus that would give me q hat, so that's 0.21. And then it tells me that the margin of error is 3.1%. So the margin of error is 0.031. Okay, so I went ahead and drew the confidence interval, but that's not really what they were asking for. They want to know Z of C. And so we are going to have to do a little extra work with this. We're going to take our formula for the margin of error. We have everything we need except Z of C, and that makes sense because we're looking for C. So let's put in everything we know. So we know our margin of error, that goes on this side. That's 0.031. That goes on the left-hand side. We don't know Z of C, that's what we're looking for. We do know P hat, we know Q hat, and finally we know our sample size. So what I did over here is I went ahead, let me put it in yellow. I went ahead and put this square root into my calculator. When I put that into the calculator, I get the 0.01275. Okay, so I put that size into the calculator and I got 0.01275. Now, I'm not quite there because I have E on this side and I have Z of C and the approximation of the square root on this side. So I want Z of C by itself. So I'm going to go ahead and divide both sides by 0.01275. That gets rid of that over here. And then I can put this side in my calculator. When I do that, I get 2.431. So basically, I'm solving for z of c. This is why we did a little bit of work of solving linear equations. So I solved by dividing by the 0.01275. That gave me z of c is equal to 2.431. Not quite there, but I'm getting there. So let's head to the next page knowing that my critical value is 2.431. Okay, so by me telling you that the critical value is 2.431 and I want to find C, I know that for Z of C and the confidence level, I'm looking at between, right? I want the area between. And what I want the area, the endpoints, I need to have, because of symmetry, I'm going to have 2.431 on the number line on this side, my Z, and negative 2.431 on this side. Okay, and that's all because of symmetry, and because this is a critical value, I know that I have to make the area be between. I'm looking for the area. That's going to be my answer. So I'm going to go to StatCrunch, normal calculator, and hit between. I'm trying to find this area in the middle. So what, and I don't know a mean or a standard deviation. So I'm going to stick with 0 and 1. I'm going to put negative 2.431 on this side. I'm going to put positive 2.431 on this side. And then I'm going to hit compute. When I do that, I get 0.985. That's my C. Okay, this is C. And I'm going to change it back to a percent if the problem wants it as a percent. Otherwise, I'll leave it as a decimal. So that one was a little trickier. That problem like that's not going to show up on the test, but it's a good problem for seeing if you're remembering everything from chapters 5 and 6.